Good morning, good afternoon, good evening, everyone. Thank you for joining our session. Today, we are going to have our guest speaker, Eugene Romero, way back from North, right? From Norway. It's southwest of Norway, from the town or city Stavanger, right? Welcome to the studio, Eugene. How are you doing?
Thank you very much. I'm doing well today. Thank you. It's a nice cloudy day as per usual in this area of Norway. So
Okay, cool. I hope you are going to enjoy some of the September before snow and all this Norse surprises are coming on your way, right?
exactly. Yeah, hopefully the weather is still passably acceptable right now. It's not too cold. So gotta enjoy it while it lasts.
That's great. And Eugene is managing cloud advisor at KPMG, and he's all into Azure. And for the people who are not aware, in Norway, Azure is one of the leading cloud solution providers where there's a lot of solutions, and Eugene is advising the customers on that. So how is Microsoft Azure in Norway? Is it like in every shop, or how well it is spread and used?
Yeah, so I was speaking actually with a friend the other day who works at Microsoft, and he was telling me the market insertion for Azure in Norway is 53%. So
Wow.
actually, Azure is the majority of for cloud services in Norway, and this is apparently the only country in the world where it's that high. Part of the reason is that some of the big players here in the Norwegian industry
Right.
made some deals with Microsoft. So Microsoft set up some Azure data centers in Norway,
Hmm.
and this made it so that like since there are now local data centers for these cloud or for this cloud provider, a lot of the clients then are going with that one by default. So it's kind of worked out good for Microsoft, I would say.
Yeah, that's great. Yeah, it's always
Mhm.
kind of, I would say very advantaged when you have a lot of advantage when in the region where you are and your customers, you have the data center, right? It's like in terms of response time, and having the support, you get the best out of the deal.
Exactly, and
Yeah.
GDPR also.
Mhm.
A lot of them want to have their
Yes.
data physically in the
Hmm.
same country, right? Mm.
And that's the biggest, I believe, probably that's the biggest reason, right? The mover to make sure that uh, data is residing on that data center within the Norway. And do
Exactly.
you have like two regions in Norway, or how it is about Azure?
Yeah, so currently there are two regions. There is
Hmm.
what they call Norway East and
Hmm.
Norway West. So the Norway East data centers are found close to Oslo, and the
Hmm.
Norway West are actually close to us here in the city of Stavanger.
Okay, that's great. All right. Uh, Coming back to the today's session, Eugene is going to have a great session about securing your apps and communications using the Kubernetes, Azure Key Vault, and TLS certificates. And now I'm going giving back to the Eugene the whole presentation stage. I hope everybody's excited about this. Eugene, it's your time. Please go ahead.
Thank you very much. Yes. So, as mentioned, the session today has to do with how to secure applications and their communications between each other using Kubernetes, Azure Key Vault, and in this particular case, for the sake of this example, TLS certificates. The reason that I wanted to do this talk is because the way to do secrets management for applications that run in Kubernetes is not always so clear. And I see especially people who are just getting started with using Kubernetes and running their apps there have issues sometimes figuring out how to get those secrets, inject them into Kubernetes. So I'm going to have some slides. I'm also going to do a demo. Hopefully it works out. The demo gods are on my side today. But we will hopefully get a better understanding then of how we can pair these two things together. So before I begin, let me make sure those are in focus. Yep. Speaking of myself a bit, I have already been introduced, so not so much more to say. But yes, I work with cloud and DevOps technologies at Capgemini. Actually, I need to update this slide because my current title is, as mentioned, managing cloud advisor. So that has changed recently. I have been over 15 years in the IT industry, especially focusing on things such as infrastructure and software development. And when I am not breaking things professionally at work, I like to break things at home, right? But in that case, I like to work more with physical things. A hobby of mine is restoring and modifying old gaming systems. So I particularly like working with Game Boys. If you're as old as me, you probably had one of those when you were younger. So I like getting those. I like restoring them, doing upgrades on them, and so on. So if you like to talk Game Boys, contact me afterwards and we can nerd out on that. Very good. So getting on with the subject of the presentation. First off, I'd like to talk about what the problem is that we are trying to solve here, right? And really, the problem is that secrets management is hard. It is difficult to manage an application and the secrets that the application needs to run, needs to be able to work correctly. If you have been in the development world for any amount of time, you've probably heard some basic things such as make sure that you are not putting your secrets alongside your code, right? You don't want to have secrets in the code of your application. You especially don't want to take those secrets and commit them to your Git repository or wherever it is that you store your code. So because of this, then we find that situation of where exactly are we going to put our secrets and how can we get our application to receive those secrets and use those secrets when it needs them. As I said, secrets and code should be kept separate, and this should be separate until runtime, right? So it's only when an application is starting to run that it should then receive the secrets that it needs to be able to do its work. Also, secrets should be automatically injected into applications. And the focus here is on the word automatically. You might think, well, since I cannot put my secrets next to my application, what I do is I write my app, and then once it's ready to run, I can manually log in and maybe put those secrets in wherever they are needed. But this is not sustainable. This is something that you don't want to be doing. You want to have a system and a process where your secrets get automatically injected. You don't have to do anything, there's no human intervention. And that way, anytime there is an upgrade of your application, or maybe a new copy of your application spins up, or whatever, these secrets are automatically put in there and you don't have to do anything. Because if you yourself are the one who is manually managing these secrets and putting them in your app, it's going to be very frustrating, it's going to be annoying. You're probably going to start looking for a new job soon. So definitely avoid doing that. So what is a solution to this problem? And I wrote a solution here, not A as in A and B, but A as in one of, right? I'm saying this is a solution because there are a couple different ways of solving this situation. I'm going to talk about one of them. So this is not the only way to do it, but it is one way in which you can solve this issue. The solution that I'm going to discuss today is based on Kubernetes. So first off, you should have already an application that is running or you are planning on running in a Kubernetes cluster. I'm going to be discussing a tool today that works closely with Kubernetes. So that is why this is the first part of this puzzle. Then I'm also going to use for the purpose of this demonstration an Azure Key Vault. A key vault, or what is called generally a vault, is a secret, or not secret, is a secure location for storing secrets, keys, certificates, anything like that. So every cloud provider has one that you can use. There's also a few others that you can obtain and run separately wherever you want. For the purpose of today's demo, I'm going to use an Azure Key Vault. Finally, the glue that ties these two things together is called the Kubernetes Secrets Store CSI Driver. And I like to joke that the people who created this product did not have a marketer because this name is a mouthful. This name, I work with this stuff and I still never remember the name of this tool. I constantly have to go back and find and look up what the full name is. I like to call it the secret provider just for simplicity, but this is the full name, the Kubernetes Secret Store CSI Driver. This is an open source tool that you can find online, you can use. I can actually show the website for it. Where's my mouse? Here it is. I will have the link to the website at the end of the presentation. But yes, this is a tool that is currently being actively developed and that is being developed very closely to the Kubernetes Foundation and those who are working on Kubernetes itself. So it is actually considered a best practice when it comes to Kubernetes to use this tool. All right. So speaking about this Kubernetes Secret Store CSI driver, The definition of it, according to its documentation, is a system that integrates secret stores with Kubernetes via a container storage interface, or CSI volume. And now this is also a big mouthful here. A CSI system or interface is a system that Kubernetes uses to connect some sort of storage to an application's pod or an application itself. So if you have an application running in Kubernetes that requires some sort of storage, you would then use some sort of a CSI interface, or yeah, a container storage interface, right? So what this tool does is that it makes the secrets available as volumes that can be mounted in your Kubernetes applications. You can use it to collect secrets, keys, and certificates from different secrets providers or secret stores, and then mount them into your application and make them visible to the application itself. So this might be a bit confusing now, but we'll hopefully it will make more sense once we get into the demo and show how it works. So let's go on then and talk a bit about this demo. And before I start with it, I want to talk a bit about what the scenario is and what we're going to pretend that we are doing here, right? So first off, when I was building this demo, the scenario I pictured was a company with internal resources. If you work in any industry that uses IT services, and that's probably the large majority of those who are watching today, if this company is mid-sized or larger, chances are you're going to have some internal resources that are only available to your internal computers and applications. What do I mean by this? This can be websites, can be APIs, this can be different things that are only internal and that can only be reached internally. So, as an example, if you were to take, for example, a brand new laptop that you just bought at the store and you try to access those sites or those services through that computer that has not been set up with any of the secrets or the internal CA authority and so on, you would not be able to access those things. For example, when I was doing this, I was thinking of one client that I work with where we have, amongst other things, we have an Elasticsearch sink, which is where we throw our logs from all our different applications. This sink is internal to this company's infrastructure, and it has an endpoint, let's call it the sink itself, which is only accessible internally. And it is protected with HTTPS. But to be able to securely use this HTTPS connection, you then have to have the internal certificate that the company uses for its internal resources. So I hope that makes sense. So yeah, this company would have then an internal CA authority, as mentioned, and the applications would need to access these internal sites over HTTPS. And I'm using this scenario with HTTPS because in this particular case, I am going to be setting up a TLS certificate that a client can use to communicate with a backend server. But this tool can also be used, as I mentioned, to inject any other kinds of secrets. So anything that is a secret that you want to have but you should not have in your code can also be set up in this same way. The components for the demo today, I'm going to be using Kubernetes, and in this case, I'm going to be using the Minikube flavor of Kubernetes. You might be familiar with Minikube. What it is basically a very tiny Kubernetes that you can run locally on your own computer. It is, however, full-featured, so everything that you can do with a large cluster, maybe a managed one on a cloud provider, or maybe one that you spin up and develop and maintain yourself, but that you use in production for your services. This has the exact same feature. So anything you want to try running on those, you can also test in Minikube. So it's quite perfect for the purpose of this presentation. I'm going to be using the Azure CLI. So this will help me set up some of the things I need to get ready in Azure first so that we can use them for the demo. And finally, I have set up a Helm chart, which is the one that holds all of the different bits of this whole system. I'm going to be going over the Helm chart itself, and I'm going to be showing what the different elements are in it. And at the end, too, I'm going to share the link to the GitHub repo. So if you want to play around with it, it has some clear instructions. You can just download it and just look through it, maybe copy some bits if they are useful to the projects you are working on. But yeah, I will be sharing that at the end of the presentation. So it's time to do the demo. I have done this demo a bunch of times and it has worked every time. I did it this morning even. I ran over the whole thing and it did work fine. Hopefully this remains the case now going forward, but let's see. Let's see what we can break. So to begin with, I am going to go to my terminal first of all. And the first thing I'm going to do, let me get my list of instructions up here. Very good. So the first thing I want to do, I have cloned down the repository with the Helm chart and the other bits, and that is now where I am sitting here in my terminal. So this is the root of that repository. The very first thing I want to do then is create a key vault itself. I have an Azure subscription of my own, which is what I'm going to be using for this demonstration, but I don't have a key vault in it that I can use yet. So first off, I'm going to create a key vault so that I can use it now for my Kubernetes applications. So the first thing I want to do, yeah, is the text too
Hey,
small?
hey again. Yes, it's too small. Can you just
Okay,
zoom in, please?
no problem. Let's see. Let me actually use this. Let me know when it's acceptable. Is
A
that
little
good
bit
or a bit
more.
more?
One more.
A bit more?
That's great.
How's that? Yep,
That's
perfect.
awesome. Now, thank you.
All right. So key vaults have to have a unique name and or specifically talking about Azure key vaults, they have to have a unique name. And I want to say this might have to be a unique name globally. Might not just be enough with it to be unique within your own Azure organization. So what I'm going to do for that, just for simplicity, I'm going to let the terminal create a name for me. So I'm creating a variable called kv, and this is just going to be called ksscd-demo-something. So this is now set to something. I'm not sure what the terminal decided to set this to, but now I have a name that I'm fairly hopeful is unique. So the next thing I'm going to do then, I am going to log into the Azure CLI and connect to my Azure subscription. So first off, to do this, I am going to use the Azure CLI Docker image that Microsoft provides in the Docker Hub. This gives me a fully featured Azure CLI environment that I can use to run my Azure CLI commands. So once I run this, I am now, you can see that my terminal has changed. I am now running inside of that CLI Docker image. Now it is running as a container, right? So inside of here, what I'm going to do, I'm going to do an Azure login. And this is going to give me a code, this one, that I can use to authenticate on this site here. So let me go to my browser and let's go to Microsoft.com device login. Put that code in there. Yes, that's the one. Am I trying to sign in? Yes. All right. So I should now be signed in to the Azure CLI. I should see that in a second. All right. So now that I am in there, the first thing I'm going to do then is create a resource group. If you're not so familiar with resource groups are just a folder where you can put Azure resources in. So this is just going to be a new folder I'm creating for the purpose of this demo. I'm going to name it KSSCD demo. I'm putting it in the West Europe location. So we create that. That is now in place. Now inside of there is where I'm going to create my key vault. So I got the command for that here as well. This command, fairly simple. I'm just saying create a key vault. The name, as you see, is set to that variable that I created earlier on. So I guess we will see then what that name is set to. I'm going to put it inside of that resource group that I created and in the same location, West Europe. So let's run that. This will take maybe 30 to 60 seconds. And while that is running, I will show how I'm going to now create a TLS certificate that I can put inside of that key vault. This is a little bit, it's not 100% needed if you just want to find out about how this tool itself works for injecting these secrets. But since we have enough time, I kind of wanted to show every single step to run this entire demo. So for the purpose of it, since I'm creating a key vault, I'm also going to create a certificate that I'm going to put in there. We're going to assume that that certificate is the one that my company, my imaginary company, is using for its internal communications. So to do that, I'm going to use this file called certificatepolicy.json. And the main things to notice here, I'm creating a certificate of type RSA, not a very big key, 2048. It's going to be a type PEM file. And really, the most important thing here is the subject. So this is the URL that will be able to authenticate by using the certificate that we're going to be creating. Now, you might be looking at this and thinking, yeah, but do you own company.com? I do not. I'm going to pretend that that is the internal name for my my company's communications. Actually, I should probably zoom in here as well because I'm guessing this is pretty small. Yeah, so this should be the same one. Let's do this. Maybe that's a little bit better. Maybe that's a little too much. I can't actually see what I'm doing. There we go. Yeah. So we're going to pretend that my company owns company.com and its internal communications also go over this company.com domain. All right. So back to our terminal here. Our key vault has been created, and let's see if we can find the name of it. This would be the name that my key vault has. So it's not so important that we memorize this or remember it anyway, but at least we now know that it's there. And as I mentioned, this has to be a unique name. I'm pretty sure it's globally based on the ending of the URI. So yeah, so I got that thing in place now. So let's create the certificate. I'm going to go into a folder that is mounted inside of my container here. Make sure I'm in the right place. Yes, so this is also the root of the repository that I am showing here. And what I'm going to do, I got another command here for that. Copy this and put it in here. So this command creates a certificate inside of my key vault. This certificate is going to be called company-certificate. Not very imaginative, but should be good enough for the purpose of this demo. I'm putting it again in the same vault that I've been working with so far. And I'm going to say the policy for the certificate or the settings of it are the ones on that file that I just showed you. So let's run that. And this shouldn't take more than 5-10 seconds, I believe. And at the end of it, we will be told if our certificate was created successfully. So there we go. So here's my certificate. There's a bit of information on it here. What we can do then is go and look at it directly. I have here my Azure portal. Let me zoom in on that as well. There we go. Let's refresh. And here is the new resource group that I created earlier. So once we go into that group, here is the key vault that was created. Entering that key vault and going to certificates, I can see that my certificate is now there. As you can see, it's called company certificate. It is active. And the main thing, again, the subject that the certificate is authenticating is company.com. All right. So that first bit is in place. So that's just some prep work. We could say at this point, this is really where the actual work begins. If you already have a key vault in place, you already have a certificate that your company uses, this is now the steps that you're going to have to follow to be able to connect these two things. So the first thing that we need in the case of Azure is a service principal. If you're not familiar with Azure service principals, at the most basic, it's just an identity. It's a user and a password, system created user and password that are stored in what used to be called Azure Active Directory. I guess it's now called Entra ID. And you take this user and you give it certain permissions. So you can say, I want you to have access to this one Azure resource. And in there, you're going to be able to read, or you're going to be able to read and write, and so on. So then what you do is when you run jobs, you use those identities to run those jobs. That way, if for some reason those identities are compromised, you only put at risk the few things that this service principal was scoped for. This is much better than using, for example, your own username or an administrator's username to run things in Azure, because then the attack surface there can be much bigger. So let's create a service principal that we can then use for the purpose of our demo. I have a command for that here, and this is Azure AD. I'm guessing that AD part is probably going to change soon, being with the name change. But so far, as of this morning, it worked. So Azure AD service principal create, and this is the name that I'm going to give it. This is the name of my service principal. Let's press enter on that. And now, important, this is going to give me some output here. This output you should save because you will not be able to see at least some of this output later on, especially the password for the service principal. This you will only be able to see right now. So if you're doing this in the command line, if you create it and then you lose a password, you can always generate a new one, a new secret. But for the purpose of the demo, yeah, let's go ahead and make sure we copy this and we put it, let's put in a new file here. There we go. We can store that there for later. All right, so we got our service principal in place. And the last thing to do then is to give this service principal permission to read secrets from our key vault. Why are we doing this? This service principal, this identity, is the one that this, let me see if I can get the name right, the Kubernetes I already don't know the name, the secrets provider tool that I'm showing. It's going to use this identity, this secret, to be able to connect to the key vault and pull any secrets that are needed. So you might be saying, but wait, where does that secret live? This secret then you would have to manage in some other way. This is something that is not changing much, and this is something that would live directly in your Kubernetes cluster. So it is okay to inject it, for example, when you create your cluster, maybe by means of a pipeline or something. So still make sure that you manage the secret in some way. But at least once those credentials are in the cluster, you don't have to think about it. And then you can bring any amount of secrets that you have in your key vault into your cluster. So to do that, then to give this service principal permission on our key vault, I got another command here, but this command requires some change. So I'm going to copy it here. What this command does, it sets a policy on the key vault that we created earlier. And we are saying this policy is for get permissions on secrets, keys, and certificates, right? So whoever has this permission will be able to read those secrets, but will not be able to change or delete those secrets. And the thing we need to change here is we need to give it, in this case, the app ID of the service principal we created. So that would be this guy right here. So let's copy that. Let's put that here. And let's take this whole thing and put it in here. So let's run that. And there we go. So this output tells me it has succeeded. Let's go then to our key vault. Where are we now? Here. Let's go back to our key vault. Within our key vault, if we check our access policies, you can see there is my identity. There's my email. So please send me some emails if you're so inclined. But once we refresh now, this is the service principal we created. As you can see, it has get permissions on keys, secrets, and certificates. So it is now able to read any secret that is stored in our key vault. And in this case, we wanted to be able to read this certificate, right? Very good. The Azure CLI part of this is done now, so we can actually exit out of that one. So now I'm back on my regular terminal. And now we're going to move on to the next step, which is setting up the Kubernetes cluster. As of this instant, I don't have a cluster running. I wanted to create it from scratch so that you can see every single step. You can see there's no additional work that I've had to do on the side. So the very first thing I'm going to do is I'm going to run minikube start. Of course, this requires that you already have minikube installed on your machine. But if you have it there and ready, this will spin up an entire cluster and it will set up your kubectl tool to already connect to this new cluster that it has created. So this is now in place. Let's do this and let's make sure that we are indeed in there. As I can see, this is showing me all the namespaces in my Kubernetes cluster. I can see that this is a very bare bones one, so this definitely has to be the one that we just created now with Minikube. Very good. The next step then, it is time to set up the chart that I created for the purpose of this demo. So before we do that, I'm going to show a bit what this chart looks like, oops, and what it is doing. So my chart is actually this guy right here, this ksscd-demo folder. I'm gonna close this. Inside of it, if you are not familiar, first of all, I should say, if you're not familiar with Helm charts are basically just a way of putting things in your Kubernetes cluster. They do call themselves the package manager for Kubernetes. But yeah, what it means is just a set of instructions that you can use to deploy stuff to your cluster. It allows you to template things and set it up whichever way you want so that it looks exactly the way you want it inside of your Kubernetes. I have this values.yaml file open here on the side just because as we look through the different files, you're going to see that some of them are templated and are referring to some of the values inside of this values.yaml file. So that way on the side too, you can quickly reference what it is that we are talking about in each one of these files. So there's three, I would say, well, let's say four distinct parts to this chart. We have, first off, we have a backend and we have a client. The idea behind this whole chart is that I want to set up the entire thing. I'm going to set up a backend, which is, let's say, the server that my client is going to try to connect to try to get information from. Let's look at that backend for a bit. First thing I'm doing is I'm just creating a namespace in my Kubernetes cluster. This is, if you are familiar with Kubernetes, you are probably familiar with what this is as well. This is just a logical partition, let's say also a folder inside of my Kubernetes where I can logically divide things into. So I'm creating a namespace. I'm also creating a service. And this is for the purpose of networking into my backend, into my server here. This one, you might see across this Helm chart, I have a variable many places called this, right? Values.tls. And you're going to see that I'm using it as a switch, as an if switch. The reason is that I made this chart to run both the TLS version and the non-TLS version. So you can set it up with only HTTP to see how that is working. And then you can turn on the TLS switch and actually set it up with HTTPS and also see how that is working. So in the case of my service here, if we're going for the non-TLS version, it's exposing port 80. If we're going with the TLS one, 443, standard ports for HTTP and HTTPS, right? And behind the service, the pod, the web server itself that we're going to look at in a second is listening on 8443 and 8080. So something to be aware of there. Finally, the main part of my backend here is a Kubernetes pod. I'm calling it TLS-server. And the main things to notice here is that, well, first of all, it is a, where do I have the image here now? Yeah, let's see, containers, there we go. It's running a Nginx image, and I'm using the Bitnami flavor of it because it allows me to configure a few more things. But this is still a pretty basic Nginx instance, so just a standard web server. Inside of here, again, the ports that it's listening on, and there are two files that I'm already mounting on it. One of them is this index.html. So this is just, let's say, in this case, it's the web page that my client is going to try to access. And also, I am mounting some configuration for the web server itself. So I'll show those two files in a second. Also, you can see if we are choosing to go the TLS route, I'm also mounting a third volume called certificates, which will also hold my TLS certificates, right? Because as you know, you need to have both. You need to have a key pair, a key certificate pair, both on your server and also on your client, right? For both of them to be able to authenticate. So let's look at those two files, the server conf and the index.html. I have those in the backend config file. In here, let's start with the server conf. Pretty basic Nginx stuff. If you've seen some Nginx stuff before, this is exactly what this is. I have an entire block for if the TLS is turned on, which is mostly telling it where to find the certificates and so on, and just my root location, which is pointing to this index.html file. Now the index.html file, which will be this bit here, as you can see, is just a bit of ASCII art. This server clearly is not very important. It doesn't have super critical information that it's providing to our clients. But hopefully, if we are able to set up this secure connection successfully, then we will be able to see this ASCII art on our client. So that's the bit about the backend itself and its configuration. I'm going to skip over these two for a second and go first to the client. And I'll talk about the other two backend files and also these two files down here afterwards. So the client, same setup, setting it in its own namespace. You can see in this case, the backend is set up in the TLS-backend namespace and the client in this other one here. It's also a Kubernetes pod. And things of interest here. This bit, for example, this is not specifically connected to the TLS part of this demo, but remember earlier I said my certificate helps us to authenticate against company.com. This here is kind of the same as using a host file on a Linux server or a Linux machine. If you're familiar with a host file, you're able to, that's kind of like the first place where the machine will go to when trying to resolve a DNS address or DNS record. So in this case, by using this host alias as part of my pod definition, I am able to tell it a pair of an IP and a host name that it should resolve to. So when we try to resolve this backend URL, which is company.com, it's going to resolve it to this IP address, which is, I did a bit of research. This is the IP address that my backend is going to get inside my cluster. So it's going to go there instead of trying to go to, wherever the real company.com is on the internet. So just a bit of a little bit of extra information there. Other things to notice, the container itself is going to be running this ASP.NET image. I just chose this because it had a few of the tools that I needed for this, but really this could have been anything as long as it can do a curl call to my backend here, right, for the demo. I will skip over the volume mount for now. I will talk about that a bit later, but let's see what the actual application itself is doing. And that's going to be this here, right? What it's going to do is just going to run a command on bash. And you see it's getting this, it's exporting this backend URL environment variable, which if it's over TLS, it'll be HTTPS, if not over HTTP. And this is going to backend URL, which again is company.com. So once that is in place, it's going to do this infinite loop where it's going to attempt to connect to my company.com backend, and it's going to give me the response. So if my HTTPS is not set correctly, curl will complain, right? It will say there's I cannot verify the certificate that the backend is providing or that this server is providing. So therefore, we're going to be getting errors there. However, if this is working correctly, we will then just be able to see our little bit of ASCII art. Very good. That's the, let's call it the basic blocks. Now let's get into the interesting stuff having to do with the secrets provider itself. So if you remember, we created a service principal earlier on, that identity in Azure, and we have to inject that identity into our cluster. For that, I have this file, Key Vault credentials, and also backend Key Vault credentials. If you see, both of them are pretty identical. Now, the reason why I have two of them is that when you set up the secrets provider in your cluster, it needs to be set up inside of a namespace. And by default, it will only be able to read secrets that are in the same namespace. So I am setting up two secrets provider, actually, one for the backend in the backend namespace and one for the client in the client's namespace. Because of that, I also have to set two secrets, one per namespace, with the credentials for, or yeah, with the ID and secret of the service principal that I created in Azure. So both of those files are the same. In this case, this is the one for the client. You can see it's being set up in the client namespace. I'm going to call it Key Vault credentials. And it has these two values, client ID, client secret. These you can see resolved to Key Vault credentials ID and credential secret, which I have here. But as you can see, these are not real values. These values will be, when I set this up, these will be replaced by this ID and this password here, right? So we'll get to that eventually. All right. So this is the secret for the service principal. Then the secrets provider itself. And this bit here is one of the most important ones in the demo. So this is the resource. At the end of the day, this is what we're trying to set up, and this is the one that is gonna be pulling the secrets in. You can see, if you're familiar with Kubernetes stuff, you can see based on the API version that this is not a standard Kubernetes resource. This is a bit of a custom resource. And its kind is called a secret provider class. So when you set up this secret provider class in your cluster, you can then tell it to do a few things. First off, you can say, well, we give it a name, of course. So this is going to be the name of the secret provider class. In retrospect, I should have named it something different because it's the exact same name as my certificate. But anyways, now it's too late to do that. So this will be the name also of the secret provider class. And I am putting it in the namespace where my client is. Again, I have the same thing for my backend. You can see this is basically also identical, but in this case, I'm doing it for the backend itself. So let's go back there. You can specify which provider your secret, your secrets are coming from, or what I should say is where your vault is located. So if you're using an Azure Key Vault, you will set up Azure here, but this secrets provider, it does support a bunch of different kinds of secrets providers. So there is a few different options. If you look through the documentation for it, you will be able to see which one to use depending on which vault you are using in your projects. We then tell it the name of the key vault that we are accessing, and this will resolve to keyvault.name, which you can see here is also just set to KV, but this we will also override when we set up this stuff in our cluster. We need to give it the ID of the Azure tenant where this key vault can be found. And finally, this is where we actually tell it which secrets to pull from the key vault. In this case, I only wanted to pull one secret, and that is this company certificate. There are a few different object types based on if I'm pulling a certificate, a key, or a secret. A secret, of course, just being any random string. In this case, since it's a certificate, I'm going to be using this object type, and this is the name of it in the key vault, right? This is the one we looked at earlier. All right. So by setting this up, I am then telling the secret provider, I want you to connect to my key vault here, and I want you to pull this secret and make it available wherever I tell you to. So how do we now make this available to both my client and my backend, right? Each one doing its own copy of it. Let's go back to the client. And if you remember, there was a bit that I said I was gonna skip over. So first up, let's go up here actually and talk about the volume. So we are setting up a volume, which we're going to call certificate. And we are telling it to use the CSI. Remember, that was the container storage interface. We're going to tell it to use a CSI of type secret store CSI Kubernetes.io. This is again a custom one. I'm going to show in a second how we set that up. But then this is the driver is going to be using for setting up my volume. It's going to be read only. I wanted to mount actually the stuff that is found in this secret provider class called company certificate. This is the one that I created here, right? Secret provider class, company certificate. Let's go back to backend. Where were we now? Volume, there we go. And finally, this is where I tell it where the credentials for getting access to the key vault are found. If you remember, this is the secret that we created in here. No, not in here, in here. This secret here, which holds my ID and password for my service principal, that is the one that I am using here. So telling it, use this driver with this specific secret provider class using these credentials. And finally, we then have to mount that into our pod. So we're mounting it. I'm creating a mount of call name certificates. I am mounting it on this path. And what's cool too is that you can set up a subpath specifically. So I'm sorry. Yeah, this certificate name is the name that we set up on the volume, right? So we're saying mount this volume. And inside of that volume, it might be that you actually have several secrets that you are pulling with your secret provider. So you can set a subpath and the subpath will resolve to, in this case, this specific one. So if I had several secrets listed here, I could tell it, I only want you to mount this one secret in my pod. So that would be this one here. And it's going to put, since I'm pulling one single thing, it's going to create it actually as a file, this file, inside of this path. One last bit then, once that is in place, if you're familiar at all with how Linux works and Linux containers work, we actually have to run an update CA certificates command so that the system actually now picks up this new certificate and adds it to the keychain. So we're going to do that as soon as the container starts, and it will add this to my certificate keychain. So that is basically all of the different bits of the Helm chart. So let's finally see it actually in action. We have to, first off, if you remember, there was a few resources that were not standard Kubernetes resources, but were custom. So to get those set up, we need to install another Helm chart, which is the Helm chart for the Kubernetes Secrets Store. Yeah, that thing with the really long name. Do I still have it here even? Yeah, this guy, this Kubernetes Secret Store CSI driver. It's not even that difficult. I don't know why I continue to not remember it. So to do that, we have to add the repo for that Helm chart. Simple stuff. You can get this from the documentation. In my case, I've already done this before. It's already in my machine, so it tells me it already exists. Then I am going to install the chart for the CSI Secret Store provider specifically for Azure. And I'm putting this in the kube system namespace. This is by definition. There is a reason for it. Go into the documentation for the tool and you'll understand why. But this will set up all of those custom resources inside of my Kubernetes cluster so that I can use them. So let's run that. Hopefully this does not fail. Perfect. So that is now in place. So the next thing to do then, now that I have those custom resources ready to be used, is to actually install my own Helm chart. I have a command for that, but to be able to use it, there is a few values that we need to set. So this is the command. I am now doing, it's an install, but with Helm, you always call it upgrade, regardless of if it is a fresh install or an upgrade. So we use Helm upgrade. The chart we are installing is this one, which is this folder here. We're going to call it this. And we are setting a few different values, right? So as you can see, we are setting the TLS flag to true because it defaults to false. And that will make sure that we set up all of the different bits that are actually TLS specific. We're also going to give it the name of the key vault, which will override this guy here. And as you can see, it's set to the same variable we've been using from the beginning of the demo. We have to give it a tenant ID and also the credentials ID and secret, or the credential secret for the service principal we created. So we have those values here. So none of these values are particularly secret, which is why I'm okay with showing them. But of course, you don't want to necessarily be publicizing them either. But according to Microsoft, none of these are secrets that need to be saved anywhere, right? Of course, if you are actually doing this for real, you don't want to be showing, for example, your app ID and password, right? But in this case, it's just for a demo. I'm going to destroy it after, so no big deal. Let's grab this one and put this one here. And finally, let's take this password and put it there. All right, so I do believe the command should be ready to go now. So let's go ahead and copy that and go back here and put that in place. And hopefully this runs. All right, so it has deployed. You can see the release, of course, didn't exist, so it's installing it now. Let's do this on the side, just because it's easier to see. Dashboard, although this sometimes takes a little while to start running, so hopefully it runs right away. This is going to give us a little nice UI on the browser, which we can use to see what is happening inside of our cluster. So while that comes up, oh, okay, now it's come up, but it's come up in another window I have here. So let's put this up here. Let's zoom in as well. All right. Let's go to the TLS backend namespace. In here, let's check our pods. And yes, it's looking green. So this is the backend that we created by means of my Helm chart. We can see that it is running. And actually, let's go in. Well, before I do that, I'm going to see if I can see the secrets custom resource definition. Probably here. Yeah, secret provider class. But this is maybe not going to show me so much about it. Yeah, a little bit. So I can see that in my TLS backend namespace, I do have my secret provider class there. If I check also the client, it will be the exact same, right? But yeah, so let's actually go into our pod and see if our secret is really there. It should be the same to go to the client or backend. It doesn't really matter. So let's use the backend here. I click on here, and here I am now inside of the pod itself, right? So I have exec into the pod. I can now see the file system internal to my backend server or my little Nginx web server here. So if you remember, and hopefully you do because I do not, where were we putting this certificate? Let me see now. We are mounting it inside this /certs folder. So let's go to /certs and what is in here? Exactly. And here we have the server CRT and server key files, which are part of my certificate. I didn't show exactly how that happened, but I did have in the backend definition, I do have an init container, which is just a container that runs before the main container, does one job, and then dies. And this one is taking the certificate from Azure and it's actually turning it into a .key and .crt files. So that is why I can see those words now. I can see those two in here. Let's see if they look as I expect. Indeed, that looks like a certificate, and this does look like a private key. So looks to me like that is in place. So finally then, I could do the same on the client, but we're going to be able to see the exact same thing. So finally then, the real test is my client actually speaking to my backend, right? So if the client is speaking to the backend, I should be able to see that it is indeed getting that output of that ASCII art. If not, it's going to be throwing an error. If you remember, the client is going to be every 5 seconds is going to be trying to hit that backend. So hopefully by now we should have um, a few outputs to look at. And actually, let's not do it here. Let's do it in here since we already have this open. Let's go to the pods, to the TLS client. And in here, can I see the logs? Logs. And indeed, as you can see, my client is attempting HTTPS company.com, and it is getting back the response that I was expecting to see. It might be, can I scroll up? No, that's as high up as it goes. Sometimes when I'm testing out this demo, if the client comes up before the server at the very top, I will see a few errors where it's not finding the server yet. But once both of those are up, and now both TLS certificates are set in place, I am now able to get that output back from my backend server. And that is basically the demo. There's a few more details I could mention, but I see that we are running out of time. So I will not talk about those for now. But yeah, as I said, the Helm chart for this demo can be found on GitHub. So here I'm leaving 3 links. One of them is to the Secrets Store CSI driver itself. So that's the documentation I showed at the beginning. There's also the repo with this Helm chart that I've been playing with. So you can also, as I mentioned, you can clone it and just play with it, kind of see what it's doing and see if you can adapt it to your situation. And also, if you want to see a written post about this same stuff, basically showing the same steps minus the Helm chart, because I didn't have that at the time, but explaining the different steps, You can see that on my website, dam.engineer. So there's the URL as well. So go in there and check that out. And that's basically it. If you have any questions, you can find me on what are we calling it these days? Xitter. So Twitter/X
You can
at
say,
Eugene Romero.
or maybe Twitter X.
Yes, exactly. Twitter X. The husk of what used to be
Yeah,
Twitter. So you can still find me in there. I still got the app on my phone. So send me a message. I'll see it. You can also find my website again, dam.engineer. That's where that QR code will take you. So yeah, that's it for my demo.
that's awesome. And Eugene, can you actually in the comments put the link so I can paste them into the chat so that people can also go
Absolutely.
there? You
Let
just
me see
put
if I
them
can
in
copy
the
them from here.
comments, like
Yeah.
chat. So, and while we are there, please put them there, and then I'll bring one of the questions. Other things are more of a comment that when you deploy Azure Key Vault, of course, the naming needs to be globally unique. That's kind of otherwise you'll get an issue with that. Um, so the question came from Richard, but I believe probably there's some misunderstanding. But can you do the same thing using Terraform so it's repeatable in terms of deploying those Kubernetes components? But
Yes, absolutely. As a matter of fact, in my real world projects,
hmm
for example, the client I was talking about, the one that had the Elasticsearch sync, there we use Terraform for setting these things up. So, really, the main steps that you would have to set up with Terraform would be mostly installing the Helm charts. So, of course, not this Helm chart for this demo, right? This is just a demo, but the Helm chart for the CSI Secrets provider that sets up the custom resources. So that we do through, I want to say we use a Terraform provider called Helm. I think it's that one. I don't think it's the Kubernetes one. I think it's the Helm one. So with that one, you can set up your chart there. And then, for example, when you are creating your secrets provider, so that would have been one of these files. That would have been this stuff, for example. At the end of the day, this is just Kubernetes YAML, right? So I'm putting it in a Helm chart just because it's one way of doing it. But you can also take this Kubernetes YAML and put it in Terraform. Terraform has a Kubernetes provider that you can feed a YAML to. So yeah, this is absolutely doable with Terraform.
awesome. Yeah. Another one that we have here is more of a comment. I believe when you were showing the workloads regarding yeah, and there's like passwords. So the one comment from Jeff came as that we use workload IDs, so no passwords required. So do you know where this comment was, supposed to be? Because
Um, yeah, sorry, I was looking through the chat to see if I could find the same one you said, but I couldn't. I didn't see it, and now I actually didn't even hear what the question was. Could you say it again? What the question was?
yes, so basically I bring the question on the screen. It came from
Hmm.
Jeff. He says that we use workload ID, so no password required. So do you know
Yes. Okay.
where he was trying to say that? Yeah.
Yes, I am.
Mm-hmm.
I believe I know what he's referring to. So service principals can also they
Mm-hmm.
can be well. Service principals. Let's put it that way. Service principals are one way of allowing access to resources in Azure. It's not the
Mm-hmm.
only way. However, you can use other things. For example, I do believe that is what this workload ID
ID.
is.
Mm-hmm.
In the case of the demo, I use the service principal because it is one way of doing it, and it's kind of easy to understand. But
Mm-hmm.
it is definitely not the only way of providing credentials to the secrets provider to be able to reach the key vault. So you can do it in a few different ways. So yeah, definitely, I do agree with the comments.
All right, good. Then we have another one. So there's like one more comment came. It's more of
Hmm.
a so thank you for a great scenario presenting that. Um, and then uh, but show static secrets in so many places in the repo, and a team member with access to the repo has access to the secrets with access to the repo. It's a bit. How would you address dynamic secrets?
Yeah. So if you have secrets, of course, here I'm showing in this demo, I showed a TLS certificate that I'm expecting not to change too often, right? So we can say that
Mm-hmm.
this is a static secret, right? However, if you have secrets that are changing regularly, the Secret Store CSI driver provider can be set up. It does have a flag that allows it to kind of be querying the key vault constantly and seeing if secrets are changing. So if you have secrets that have changed, the secrets provider will then tell Kubernetes to spin up a new copy of your application, because that is one limitation with these Kubernetes pods. If you are changing the content of these secrets, chances are that you need to spin up a whole new pod, because otherwise the application might not be aware that the secret has changed. You can use the CSI driver to, for example, put your secrets as environment variables, but that's the same thing, right? Like you need to somehow tell this application this has changed. So the way it handles it is by just killing the pod and spinning up a new version with the new secrets. But this is, last I checked, this is a flag that you do have to set manually. So it is not functionality that is enabled out of the box. I think because they were trying to prevent it automatically killing pods for no reason, right? It might be that this is not desirable, but this is functionality you can do. So when you have secrets that are changing, you can do it in that way. So at the end of the day, the idea being that you are not able to see at least the secrets not in the repository for the code, right? If you think about the code that I showed, there was no secrets that were shown there ever. The only secrets that we used was when we installed the chart, because we passed the service principal secret. But as we just said a couple of minutes ago, this can be done even in a different way so that there is no secrets there. But of course, you do have to be aware that if you have a team member that has access to your Kubernetes pods, they will be able to see the secrets if they know how to get into the pods, right? I showed you how we could exec into a pod and see the secrets inside. So if you have these secrets running in an application, they will be visible to someone with enough rights. So that is something to keep in mind, right? But that is, of course, out of the scope of this presentation, since we're just mostly showing this tool for connecting these two resources.
Yes, that's
I
really
hope that
good.
answers.
No, it
Hmm.
does. And just to back, coming back to your answer, so whenever there is a change in application, including the secrets, the idea of Kubernetes and similar systems is that you need to spin up the new nodes and then replace the existing ones, right? Because that's how you push the change into the environment. So that's kind of make
Yeah, new
sense
pods, but
from,
yes.
yeah, that kind of
Yeah,
makes sense from that perspective, how you manage the application cycle and change that you bring to your environment.
exactly. And if you think about it, when you're writing applications to run in Kubernetes, the idea is that you write your application so that it can handle dying and restarting, right?
Mm-hmm.
Because Kubernetes kind of works in that way that
Yeah,
at any point a pod might be killed and a new one put in its place. So the
correct.
application should be able to handle this gracefully.
Mm-hmm.
And yeah, and I think by default that would be the behavior for updating secrets in an application.
Yeah, great. So great. Thank you for a great demo. And that comment also came from the, viewers. That was really engaging and awesome. So thank you everyone who tuned up for our session today with Eugene from Norway. So we had a great session on application security, how we can inject that using the, Azure Key Vault services, the Kubernetes, and all the, beauty that it brings together as one of the scenarios, as Eugene mentioned in the beginning. So that's was really engaging, nice, a great demo, and thank you viewers for being here and watching it, and thank you Eugene for a great demonstration and bring this session. Thank you,
Absolutely. Thank you very much. Have a good day.
thank you everyone.